So this is ongoing work, and some of the initial sort of like lessons learned came out of a dissertation that one of my former students has completed that raised more questions than answers. So I have two of my doctoral students with me today, Scott and Batul, who have been looking some of the data that we have collected and sharing some of the outcomes.
Yeah, so hi, and thank you again for attending our presentation on examining pre-service teachers' ability to incorporate computational thinking into lesson plans. I'm Batul, and I'll be presenting the first half, and Scott will be presenting the second half. So the definition that we used for our research defines computational thinking based on these 9 components. Data collection, abstraction, or reducing the complexity of a problem, for example, to increase efficiency. Parallelization, it organizes the resources to simultaneously carry out tasks in a certain order to reach a common goal. Then there is data collection, analysis, and representation, as well as algorithms and procedures, which are just ordered steps taken to solve a problem. There is problem decomposition, which is breaking down tasks into smaller, more manageable parts. Automation, which is having computers or machines do repetitive, tedious tasks. And simulation, which is a representation of models of a process. So bringing computer science into the classroom has led to a focus on PD of in-service teachers. However, providing teachers with training is not enough. To integrate computational thinking into the curriculum also requires preparing pre-service teachers to embed computational thinking in their teaching and learning strategies. A number of interventions have led to pre-service teachers' increased understanding of computational thinking and perceptions of the value of computational thinking. One example from the University of Delaware involved the redesign of an EdTech course to include computational thinking. Results indicated that participation in the course enhanced teachers' understanding of computational thinking concepts and practices, as well as the perceptions of its value in the classroom. Furthermore, pre-service teachers exposed to computational thinking in their coursework believe that they can embed it into their classroom instruction in core areas. So as for our EdTech course, it is a required 2-credit course for all pre-service teachers taken usually during their junior or senior years. It is a 14-week course. It introduces technologies available for use in the classrooms and content areas, pedagogical considerations for use in teaching, and learning practices that combine both the use of these technologies and pedagogy. The course was offered in a hybrid form, so as you know, some sessions were held online while others were held face-to-face. So kind of another overview. This study looks at pre-service teachers' ability to create lesson plans that incorporate computational thinking using 2 different technologies, digital concept mapping tools and Scratch. So specifically, the study answers the following questions. The first one is, to what extent does the quality of pre-service teachers' computational thinking infused lesson plans differ when incorporating concept mapping tools compared to the Scratch programming environment? And our second research question aimed to answer, what computational concepts do pre-service teachers incorporate into their lesson plans when using concept mapping tools in Scratch programming? The participants for the study included 41 pre-service teachers chosen at random from a core methods class of 60 students. A power analysis demonstrated 41 participants was the minimum requirement to detect a medium effect size. Each participant was an elementary ed major in their junior or senior year, so they're undergrads. And unfortunately, specific demographic data is not available. However, we know that participants were overwhelmingly Caucasian females based on the overall demographic makeup of the program. So students in the course completed a series of assignments. This study focused specifically on pre-service teachers' design of 2 lesson planning tasks that integrated computational thinking with content following the scaffolding framework introduced by Harris and Hopper. These 2 lesson planning tasks were chosen as data sources because they help illustrate pre-service teachers' ability to apply new learning of computational thinking into the design of authentic lessons. So the first data source was the programming lesson plans. So prior to creating the programming lesson plans, pre-service teachers were exposed to 2 weeks of introductory computational thinking content, and preparation for programming using Scratch. During the first week, teachers completed readings and watched videos that define computational thinking and the differences between computational thinking and coding, and the importance of including computational thinking in the classroom. Additionally, they completed hour of code assignments in a block-based coding environment, code.org. And then in the second week, pre-service teachers discussed the role of computational thinking and its importance in education, engaging computational computer science plugged activities, and completed a series of programming activities using Scratch. Then as a homework assignment, pre-service teachers designed a lesson plan for a subject area of their choice, could be literacy or math, that integrated Scratch programming into their specialized subject areas. So for the programming lesson plan, pre-service teachers were required to include the following components in their lesson plan. So specific learning goals from their discipline, and a description on how to introduce Scratch to students, a description of the activities they'll be using, and a description of how programming could be used to help students achieve their learning goals. So the second data source was the concept mapping lesson plans. The concept mapping lesson planning assignment directly followed the programming assignment that came right after. And in preparation for the concept mapping lesson planning assignment, pre-service teachers read articles related to the role of concept mapping software in teaching and learning, the potential benefits, and then teachers' attitudes and perceptions regarding the use of concept mapping software. And then as with the programming lesson plan assignment, pre-service teachers first explored various types of concept mapping tools and different softwares out there before moving on to the actual lesson planning design. The concept mapping lesson plan had the same criteria as the programming lesson, except in the concept mapping lesson plan, pre-service teachers were also expected to develop a copy of the sample concept map to demonstrate what was expected of students. And I'll turn it over to Scott.
Okay, so the data analysis, all 82 lesson plans that we gathered, 41 programming and 41 concept mapping, were assessed using a rubric that we adapted from Harris, Graham, Gannett, and Hoffer. The rubric identified 4 evaluation criteria: curriculum goals and technologies, instructional strategies and technology, technology selection, and the overall fit, which would be the alignment of content, pedagogy, and digital tools. Each of the 4 criteria received a score from 1 to 4. A score of 1 indicated a complete failure in satisfying the criteria, and a score of 4 indicated full success in satisfying any of the criteria. The results were an aggregate score for each lesson plan that ranged from 4 through 16. I scored each lesson plan 3 times to ensure internal consistency and accuracy with the scoring. Quantitative data from the scoring were analyzed using multiple dependent paired sample t-tests. The dependent variables were the scores for each lesson plan on each of the 4 assessment categories, as well as the aggregate scores. And finally, after the final round of scoring, each lesson plan was examined to identify and code the presence of specific computational thinking concepts that were identified earlier. And what did we find? Well, the results showed that on average, pre-service teachers had a higher overall score on the concept mapping lesson plans and for each of the individually assessed categories on the concept mapping lesson plans. The concept mapping lesson plans received an average aggregate score of 11.15 out of 16, compared to the programming lesson plans, which received an aggregate average score of only 8 out of 16. So the results of the paired t-test showed statistically significant differences in aggregate scores between concept mapping and programming lesson plans. So you can see the numbers there. Everything was statistically significant. Effect sizes were large, nearly 1.99. Additionally, paired t-tests showed statistically significant differences in each of the 4 assessment categories. the curriculum goals and technologies, instructional strategies and technologies, the technological activities, and the fit. All of the effect sizes were medium, large to large. And overall, these scores demonstrated that pre-service teachers' lesson plans were of higher quality when incorporating concept mapping tools compared to when incorporating the Scratch programming environment. There was really little variation in the computational thinking concepts that were present in the concept mapping lesson plans. Out of 41 concept mapping lesson plans, 35 incorporated the concept of data, including data collection or analysis or representation. Other computational thinking concepts represented included abstraction. There were only 2 of those, and 3 of algorithms. One of the concept mapping lessons included no computational thinking concepts, and it did not, because it didn't follow the directions of the lesson. So, the programming lesson plans exhibited a lot more variation, Of the 41 programming lesson plans, 18 incorporated algorithms as the primary computational thinking concept, 17 incorporated data, 2 incorporated simulation, 1 abstraction, and 1 decomposition. 2 of the lesson plans for the programming didn't include any computational thinking concepts. They didn't fulfill the goals of the lesson. So to give you an example of some of the lessons that we had, one particularly good example of the algorithms in computational thinking was students creating different arrays of boxes on Scratch. Students were told to create an array of objects, so boxes, faces. They could choose what they wanted to, 12 for an example, and then they had to create a program that would create random arrays of like 1 by 12, 2 by 6, 3 by 4, for example. This was done after students had created the same arrays on paper first to determine an algorithm that could be used when programming. A particularly illustrative example of the data in computational thinking was the use of the concept mapping tool for a civics lesson. Students were directed to categorize the branches of the federal government along with their duties, responsibilities, and members to create a visual categorization of the data. So our discussion. Our results demonstrated that pre-service teachers were significantly better at creating lesson plans using digital concept mapping tools than they were at planning using the Scratch programming environment. This may be explained in part by pre-service teachers' prior exposure to concept mapping and its wide use in both K through 12 and higher education, meaning that they were more comfortable using those tools. In contrast, the pre-service teachers had far less exposure to programming, since programming isn't required part of the curriculum for most schools. Interestingly, there was less variation in the computational thinking concepts presented in the pre-service teachers' concept mapping lesson plans than in their programming lesson plans. Out of the 40 concept mapping lesson plans, 87 to 88% revolved around the collection, analysis, or representation of data. The focus on data in the concept mapping lesson plans is understandable, though, as concept mapping tools are really designed for visually representing connections among data. In contrast, the pre-service teachers' programming lesson plans incorporated a wider variety of computational thinking concepts. Notably, the computational thinking contained in most of the lessons fell into 2 categories, algorithms and data. However, there was more differentiation and some creativity in how computational thinking was incorporated in the programming lesson plans. I'd like to talk a little bit about our limitations as well. Although the pre-service teachers had been introduced to Scratch prior to the design of a programming lesson plan, we don't know the extent of their learning of programming. It's possible that the 2-week module was insufficient for preparing pre-service teachers to use these programming tools. The pre-service teachers may also have had a naive understanding of computational thinking, making it difficult for them to incorporate a wider variety of computational thinking into their lessons overall. And as a result, pre-service teachers gravitated towards the computational thinking concepts of data and algorithms because those are concepts that they have more familiarity with through other disciplines such as science and mathematics. And that finding would be consistent with others that have found pre-service teachers focus primarily on the computational thinking concept of data while enrolled in a science methods course. That would be a McGinnis study. So to summarize, the study demonstrates that pre-service teachers can create lessons using digital tools that incorporate computational thinking with varying degrees of success. Pre-service teachers were much more adept at creating lesson plans with concept mapping tools as opposed to Scratch. It's likely because of their familiarity with the concept mapping in general, as opposed to their familiarity with the tools themselves. Pre-service teachers' limited exposure to the programming tools most likely played a major role in the lower quality lesson plans using Scratch. But we know that the choice of digital tools can affect the type of computational thinking concepts that pre-service teachers incorporate into their lessons. Thank you.